So, what is a tree? Tree is basically a non-linear data structure. So far, whatever data structure you have learned, maybe a linked list or an array, they are all linear or list-like data structure. Whereas a tree maintain a hierarchical structure, which is non-linear in nature. Or to clarify it more, each node of the tree are related with a parent-child kind of relationship. The left-hand side picture can help you visualizing what is the meaning of the hierarchical structure or parent-child relationship. Here, actually, each parent node contains the address of more than one different child nodes. So here is the exact difference between a linked list and a tree. In a linked list, each node basically contains the address of only one node, that is the next node. Or sometimes in case of doubly linked list node, it is just the either next or previous node. But in a tree, basically each node holds the address of many different nodes inside it. For example, in this left side picture, A is a node which holds the address of node Z, node P, and node H. Now, in a tree, the first node in the hierarchy, the top node in the hierarchy, has a very special name which is called a root node. The nodes at the last level also has a very special name which are called a leaf node. So root node is the top level node and the leaf node is the bottommost level node which does not have any child under them. Whenever it comes to a leaf node, you can imagine that each leaf node is basically pointing to null. So why do we need to use tree? What is an example of tree? Tree can be found in any organization, either in an office or uh, any different types of organization. So for example, in an organization, in the top level there are owner. Then for example, this root in an organization can be an owner. Then in the next level there can be several manager. So let's say Z is a manager, then P is another manager, H is another manager, and under the manager there can be more worker, like that. So any organizational structures mostly follow this tree type of data structure. Now, what is binary tree? Binary tree is basically a special type of tree where a parent can have a maximum of two children. That is either zero child or one child or two children, no more than that. So here basically in a binary tree, each node contains the address of two different nodes. The first one is a left child and the second one is the right child of that node. And well, one more thing you should notice, that in each level of the hierarchy, the structure can just repeat itself. For example, A is the root node because it is at the top level. Then A has a left child and then a right child. P is the left child and Z is the right child of A. Now, just try to see the tree from this level. Now, if you just close the A, then also from the second level also, starting from any of the node, either the right child or the left child, you can see the similar type of structure is repeating. For example, Z has a child H. Now Z could have another left child like this. Let's say this is my C or something. And in this way, it can repeat. So not only the first node, well, first node is called the absolute. You can think in this way. The first node is the absolute root of the entire tree, but in each level of the tree, you can connect each of the node with the parent-child relationship, where parent can be called root and all of their children are just either can be either left child or can be right child. So this is what a binary tree is, and in a data structure there are lots of use of binary tree, and there are many different types of binary tree with different types of restrictions. So in this course we are going to learn how binary tree can help us in doing better searching in a group of element or better sorting of a group of element. Both the things we are going to learn, and to for different types of purpose, say searching or sorting, each binary tree comes up with different types of restriction and different types of operations. Those things we are going to learn in the next few videos.